Hello, my name is Touma. My ID is 6359553, and this is the first lab report from Group 2.
Hello, I am Hannah Contramaestre. My Panther ID is 6117264. This is for course EEL-3110C, and I did questions 1 and 2.
Hello, my name is Mohammed Alsabbaghe. My ID number is 57317.
Okay, so for question number 1, what I did was basically I drew the circuit on the multisim, and then for the readings for B, C, C, E, D, E, I got 0 because it is an open circuit, so it should be 0. And for the current that I got was 5 divided by 2.7 because of the resistor, so you have to divide the voltage by the resistor and you get a current of 1.85. That's basically what I did for number 1. And for number 2, okay, there we go. For number 2, I had a little bit of difficulty just because since it is also an open circuit, the indicator BC should be 0, but I tried many different ways and I wasn't first I for some reason wasn't getting 0, but I know it should be 0. And so basically, I also should be getting 0 for the indicator too, because again, it is an open circuit, but I don't know why it's not working. And I consulted other fellow class members and we couldn't figure it out. And so basically for number 2, the readings for the indicator indicator for number 2 should be 0 and for BC should also be 0. But the voltage I got for not the voltage, sorry, the current that I got for the first one is 7.3 divided by 5 because that's the second resistor and it should be 1.46. And then yeah, we basically just drew the whole entire circuit, and the readings should be 0 for the indicator 2, BC, CD, and DE. Thank you.
Here in the third activity, we have a series circuit, and we are asked to determine RAB, which is the total resistance, which we get by adding R1 and R2 in this case. The objective is to see in the different scenarios that we have, A, B, and C, how the total resistance changes compared to resistance 1 and resistance 2. Here in the first scenario, I had to make sure the first resistance was bigger than the second one, which in this case is true because the first resistance is 2 kilo ohms and the second one is 1 kilo ohm. And to get the total resistance, we just have to add them, like I said before. So it's 3 kilo ohms in total. In the second scenario, the only difference is that the second resistance has to be bigger than the first one. So the first one is 2 kilo ohms and the second one is 3 kilo ohms, giving a total of 5 kilo ohms. Here in the last scenario, both resistances had to be the same, which in this case is 1 kilo ohm. And of course the total is basically doubling it, so it's 2 kilo ohms. So basically in this experiment we can conclude that the total resistance in series circuits is always going to be bigger because it's equal to the addition of all the resistances in the circuit. Here in the fourth activity, we had to create a bigger circuit with 2 resistances, 3 currents, 3 nodes, and 1 voltage, where the voltage had to be bigger than 0. I used 12 volts. And we have to use the formula provided with each case scenario to see how the current, voltage, and resistance changes. Here in the first scenario, the condition was that R1 had to be bigger than R2, which in this case is true. And to get the total resistance, we just add them because it's a series circuit. So it's 3. Then we get the 12 volts and divide it by 3, and that gives us 4 amps, which is the current that's not going to change throughout the circuit because it's a series circuit. Then with that current, we can determine the VAC and VCB by just multiplying by the different resistances, which in this case are 2 and 1. So 4 multiplied by 2 is 8, and 4 multiplied by 1 is 4. In this scenario, R2 had to be bigger than R1, which in this case is true. And then we just use the same methods that we used for the first question. So it will be 12 divided by 6, which is the addition of the resistance, giving a result of 2. And then 2 multiplied by 2 is 4, and 2 multiplied by 4 is 8, which are the corresponding VAC and VCB. Here in the last scenario, both resistances had to be equal, which is true. And then we do the same procedure, adding them using the number to reduce the voltage, giving us 6 amps as the continuous current throughout the circuit. And then for both resistances, it's going to get the same answer for VAC and VCB, being 6 in both cases. We can conclude with this experiment that the current is never going to change in series circuits because it's always constant, but the resistance can reduce the value of voltage in different ways throughout the circuit.
Hello, my name is Mohammed. This is for question number 5. I'm responsible for 5 and 6. This was the drawing that I ended up getting. The numbers look pretty good to me. Did it all over here. Came out fine. Basically, you just put the multimeter, the resistor, and you just connect them all. And then when you put this, it gives you the numbers. For the second one, it was a little bit more tricky. You have to do a little bit more stuff. I think I got most of it right. Need more practice on it. But yeah, that's pretty much it.